can start this. Hello guys, welcome you all for this end-to-end program of AIML where you guys gonna learn everything from scratch now to become a successful data scientist. Hope you guys are enjoying the sessions. So because like we have done nearly 25 plus sessions and we are now moving on to the coding part of what we have learned so far. So last previous session is like a summary session where we have done entire concept in a summary. Last session is a coding session. Today we're gonna continue the coding session, guys. So hope you guys are enjoying. If you guys have any doubts, okay, related to till the step that we have done, please make sure that you guys have noted down and list it in the comment section. We will take it up and we will just clear the doubts, okay, because like we are here to help you, okay. So don't worry about it. If you have any doubt, just post it in the group, like post it in the comments, and we will take it and we will make it ready, okay. So before coming for this session, please watch the previous session at least so that you can have a continuation. So the continuation of previous session. So yeah, so without wasting any time, just we will jump into this session. So yeah, I will just say a glimpse of it. Last session we have just looked into how we can load the dataset and how we can pre-process the dataset using Python. Okay, this session we're gonna see how we can manipulate the dataset and then data visualization. Then we're gonna wrap up this data. Okay, and then we will jump into machine learning. Okay, I think like you guys gonna be excited with machine learning. Only 2 lines of code. Okay, now we're gonna learn. Okay, yeah. Before going further, we will just complete it. Data manipulation. Now let's demonstrate how to manipulate the data by filtering and grouping. Now, before going for this, I will just show what is the data set that we are using. Okay, so that you can have a better understanding. If you guys doesn't watch the previous session video, okay, I will show the pre-processed data. Yeah. So guys, this is the data that we are using. Okay, so it is an iris data set, and we have done some pre-processing. Okay, please watch the previous session video so that you can have a continuation. But I will say what is the dataset that we are using. Yeah, this dataset is an iris dataset which will tell what type of flower it is based on the we will say based on the features that is had. Sepal and sepal with petal and petal with, it will say what is the species, like Setosa, virginica and vesicular, and we have just encoded it also because like machine can understand only zeros and ones. We have encoded it. Okay, so yeah, till this point everything clear. This is the dataset that we're gonna use. Now coming to this data manipulation, first we will do the filtering. Okay, how I can do the filter. Iris is the name of the dataset. Okay, that is what I have given while printing. After printing, okay, let's see. Okay, iris dotted, it will print the first 5 records. So you guys can see iris is the dataset name. Okay, I'm just doing the same thing. Iris within square brackets, I'm just giving iris. Petal length should be greater than 1.5. Now the entire dataset will be filtered wherever the petal length is greater than 1.5. It is a kind of filtering. Now I'm gonna print the filtered data. Okay, hope you guys have understand this. Now you see the petal length is greater than 1.7, right? So sorry, 1.5. It is 1.7, 1.6, 1.5, 1.7, 1.7, 1.7. So this is how I filter the data. This is a kind of manipulation. Now the record, that is a filter record, will have the data whose petal length is greater than 1.5. It is a kind of manipulation. Now let's see grouping. Okay, now you guys see here. Okay, before that, after filtering, that is petal length is greater than 1.5, we are having only 112 records, that is 112 records and 6 columns. That's not a matter. But in the original data set, that is a pre-processed data set, as the shape of 149, that is 149 records are there, whereas we have filtered records based on the petal length greater than 1.5. Now we are having only 112 records, that is nearly 47 records are missing. Missing means we are removed it based on filtering. Okay, hope you have understand this. 47 records are thing, because like 149, right? So 49 minus 12, it will be like around, I think it is 30. So 49, 37, I think so. Okay, so 37 records are filtered based on this condition of petal length greater than 1.5. Okay, now let's see grouping. Now what I'm gonna do means i'm gonna get I'm gonna group species and calculate the mean of each numeric column. Okay, how I can do it? Iris is a dataset name. Group by which I'm gonna group species. Okay, it's a column, and I'm gonna get the mean. That's it. If you print the group data, you guys see here, sepal length, sepal width, petal width, and then species encode. Setosa, the mean value is 5.0 for sepal length. Vesicolor, the mean value for sepal length is 5.9. Whereas for Virginica, the sepal length mean value is 6.6. Like that, for all columns, what is the mean value for this species? Because we have grouped based on species and we have added one aggregate function, that is mean. I hope like you guys can understand, right? Now we have done grouping. Okay, just see the explanation. We have filtered the dataset to include the rows where the petal length is greater than 1.5 using Boolean indexing. That is, if you doesn't put this brackets, right, this iris and this starting bracket and this ending bracket, right, what happens means you guys will have a Boolean value, that is true and false. Since you have put in this square brackets and iris, you are getting wherever the true is there, the record is written. That's the thing. Okay, hope you can understand this. Okay, that's a major thing. That is how we have filtered the things. Now we group the data by the species column and calculate the mean of other numeric columns using group by and mean. Right. So we have done a grouping by using species column and we have took the mean of it. It's an aggregate function and we are getting the mean of each and every column based on the group species. Okay. Hope you guys have understand this. This is how we can do the data manipulation in the data set. Okay. So I will just go above. Okay. I will just hand it over to sir. Yes, sir. Over to you.
Yeah, data manipulation is very, very important, guys. That computers actually are built and all the programming that is for data manipulation, guys. If you see fundamentally, the core of computing is data manipulation. Huh? And when it comes to programming and all these things, so data manipulation is very important. So here we will demonstrate data manipulation dataset by filtering and grouping. Okay. So filtering dataset includes rows and where petal length 1.5. Suppose, okay, filter data equal to iris petal length 1.5. Then print the filter data petal length 1.5. So filtered data dot head. So it will show, it will demonstrate, it will filter here with this function will be filtering the petal length, okay, uh, by 1.5. 1.5 will be the petal length, we'll be filtering it like we do filter, right? We do filter in your application, we do filter the uh, uh, minimum cheapest flight or the best flight, like, so we do filtering, kind of sorting. Here also we'll filter based on specific value. So and then we'll say filter dot head according to that. So it will filter, yeah, it will filter uh, greater than 1.5, sorry. So it will filter greater than, right? Greater than. So you will see the petal length in the data set is greater than 1.5. Okay. You will never see, because that's a filter. We have applied that function to get the petal length greater than. Okay. So suppose we can write a code less than 1.5, then we'll have lesser. So we can manipulate data with filtering. That is the ultimate concept, right? So we can manipulate data according to filtering, and then we'll see the shape. Yeah. So this is the output, and we have 122 and columns and rows we have. Okay, so that is the shape after filtering. Before filtering, it would be more, right? So that this is how we can manipulate data with filtering. Then we go grouping. So we again put a condition. Here would be a condition like grouping will be doing based on iris dot group by species. Species is one of the group. Okay, based on species we'll group. That's very simple, logic. Understand the logic, don't go with lot of text, and it looks like human eyes when they see lot of text, lot of numbers and text, so we get overwhelmed. So just understand the logic. Iris dot group by species. This is what dot mean. So print mean of the feature grouped by species. That's it. Okay. Then you will get group data according to the species. So what are the species? We have three species here. Okay. Uh, we have set Setose, and we have Virginica color, we have Versica color, we have Virginica. So these are three species which we have, and then we have sepal length, okay, sepal width, petal length, petal width, and species encoded. Because machine learning, these are not quantum computers, so you have to understand, we have to make it so simple to computers in binary, okay, zeros and ones. Okay, we have to make it, we have to encode it so that computer understands that in a binary, which is like ASCII standard. If you have gone through, guys, if you have not, just go through it and understand every word, every thing is coded, okay, to a binary, so that computer understands and machines understand that through electronic flow of 0 on 1. Okay, so this is how computers understand, because they don't have consciousness, na? We can understand a lot of things, hidden meaning, not hidden meaning, out of context, in context. We human beings have different. So machines can understand only until unless we have quantum computers which will have superposition, which can understand multiple uh, ways and multi-dimensional. So the explanation here is filter the dataset to include rows where petal length is greater than 1.5 using Boolean indexing. Okay, so you know Boolean indexing, guys. Okay, so Boolean logic is true or false. Okay, it works on if you have gone through gates, it works on either yes or no, right? So Boolean logic, it's like very simple for computers. Okay, so that is why we use Boolean indexing and all. Okay, then we group the data by species column and calculate the mean of numerical column using group by bracket. Okay, so we'll use this group by, and in brackets we'll put the kind of group, species, the group, or other. It can be XYZ, whatever group you want to manipulate, like through grouping. So you can put and mean bracket. So in mean bracket, uh, you have to just write it dot mean bracket, and then you have to print mean features group by species. So you have to give command also that what it has to print. So you have to, computers are so dumb, I'll always say this. You have to give specific instructions. It's everywhere in any programming, I'm saying. So you can say you are teaching unconscious machine, unconscious program to be conscious with specificity. Like an illiterate person, you're guiding him that bring a book from the shelf, second, from the left side, second book. So being very specific, same way computers work. Your command, your functions, your all the instructions should be very specific, guys. Remember this thing, okay? So this is how we do data manipulation. So I have my way of explaining things. Raj has his way. So here you are revising in a no time, and reinforcement learning is already happening, guys. So in application, reinforced learning is happening. So this you will find nowhere on entire Google, because we are making things so simple so that anybody can learn, even if, if he has 30% or he has 90%, anyone can learn. Or he is dumb, or he is intelligent, anyone can learn. So that this is the future, guys. If you are not learning AI, if you are not learning AIML, you are not learning data science, you won't be employed, I'm telling you. Or if you want to have a startup, you need to know all these things. They are essential, like air. Breathing air is essential. Data science, AIML is essential. So keep learning. Thanks. Let's move to the other section.
Yeah, sir, sure. So today we have just discussed data manipulation. We will move on to the next one. Okay, data visualization. Let's create some basic visualization to explore the data. Okay, yeah. Today in this we're gonna use Seaborn. I'm gonna just display some things. Okay, let's see. What is the first thing that we're gonna display is we're gonna create a scatter plot, guys. This plt dot figure fix size equal to 12,6. What it will do means it will fix what is the width and what is the height. Okay, you can see the plot here, right? It will be in the width it will be 12 and the height it will be 6. Like that we are just fixing the size of the figure. Now I'm going to print the scatter plot by using the Seaborn library. I have just already imported it by using import Seaborn as CSNS. I will just show the things to you. Okay, I think it will be, yeah, here. Okay, you guys see here we are imported import Seaborn as SNS, and also this also required pyplot. Okay, matplotlib.pyplot as plt. Whenever I need a matplotlib, I will go for matplotlib.pyplot. I will be go for plt, whereas I need a Seaborn, I will go for SNS. Okay, you guys just go down. Okay, now see here SNS, that is Seaborn scatter plot. In x-axis I need a petal length, and in y-axis I need a petal width. Who is the color? Species is the color. And then I'm going to use the dataset called as iris. Iris is the dataset name. That is a variable content. And in title, I'm just putting petal length versus petal width by species. And I'm just using plt.show. Guys, see here. This is what the plot. Petal length versus petal width. And we have plotted the data points. And data points colors is based on the species. That is, this blue color is called as setosa. This green color, this orange color is called as versicolor, and this green color is called as virginica. Virginica. Okay. Is it enough? Okay, we have done a visualization. Is it enough? No, right? We need to get the inference from it. Guys, I will give a 10 seconds of time. Just look into, just have a look into this figure. I will just explain. Okay. Okay. Hope you guys look into this figure. Okay. First thing comes to my mind. The characteristics of setosa flower is far different from versinica and versicolor. Versicolor. Okay, virginica and versicolor. It's true, right? Guys, see here. This is versicolor and this is virginica, and we are having setosa somewhere else. Okay, so setosa flower is gonna be completely different when compared to versicolor and virginica. This is what the first inference. Second inference, there is some correlation, right? There is some correlation with versicolor and virginica, right? That's it. That's the inference that I'm getting from this graph. Guys, one thing, anyone in this world can do visualization. How you gonna give the inference to the client that gonna make the change? Okay, whenever you have a visualization, you guys need to say this is what is happening. That's a major point of any data scientist, I will say. Okay, let us move to the next visualization. Okay, now I'm going to create a new data frame that contains a sepal length, sepal width, petal width, and species. I doesn't need the species encode column. We are having species encode column, right? I doesn't need that. I'm going to remove that. So I'm just mentioning all other columns. Okay, that is sepal length, sepal width, petal width, species. Okay, It doesn't need species encode, so I'm just creating it and giving it to the new iris. So this is how the new iris dataset looks: sepal and sepal with, petal and petal with, and then the species. Now it doesn't have species encoded because I doesn't need it for the next visualization. Now similarly, I'm just setting the with the height of the figure. Now I'm going to do the pair plot. SNS.pair plot. I'm going to give the dataset new iris which I've created now, and hue is species. Okay, you can see the colors, right? In this, what that hue is doing, hue species means setosa it will give the blue color, versicolor it give the orange color, and then virginica it gives the green color. Like that, for the hue means it will give the colors. Similarly, a hue means species, it gives the colors. Then I'm gonna give the super title, that is SUP subtitle, pair plot of iris figure, and I'm giving the y-axis, giving y-axis of 1.02, that is a spacing from the top, y-axis spacing. Okay, 1.02. I'm just going to show the figure. Okay, this is a pair plot, guys. You guys see here, sepal length versus sepal length, and sepal length versus sepal, then sepal length versus petal length, sepal length versus petal width. Like that, for the entire features, you guys see here, sepal length, sepal width, petal length, petal width, sepal length, sepal width, sorry, petal length, petal width, petal length, sepal width, sepal length. Okay, I will put it in this manner: sepal length, sepal width, petal length, petal width. Similarly, sepal length, sepal width, petal length, petal width. But is it is gonna find the correlation between all the features inside this dataset. I'm giving a hue, that is whenever there is a blue color, it is setosa, orange color is vesicolor, and then green color is virginica. Okay, that's it, guys. Okay, now I will give 15 seconds. Okay, look into this. Let us discuss what this graph is saying. Okay, just look into this graph. Okay, let me say the inference. Okay, sepal length and sepal length, it will create a distribution plot. That is, when it comes to setosa, the sepal length is very high sometimes when compared to the petal length, like sorry, versicolor and virginica when come to sepal length. When it comes to sepal width, there is a overlapping between versicolor and virginica and somewhat lesser for setosa. Then petal length, setosa is completely different, whereas virginica and vesicolor is somewhat binding. Okay, when you want to do a distribution or want to remove the setosa from these two things, you just need to consider sepal length. That's it. You need to consider the lesser sepal length. Okay, because it is first, right? If you consider only lesser sepal length, you can remove this setosa for you. Okay, these are the inference that we are getting from the data set, guys, using visualization. Now when it is petal length also, the setosa is separate. Okay, so by using petal length and petal width, you can just remove the setosa for alone. So because the other two are overlapping. Okay, this is what this diagonal is saying. Let us give a glimpse of what the other things except diagonal stays will come here. Okay, what is this? Sepal length, sepal width. Okay, see here, vesicolor and virginica are down and they are overlapping, whereas setosa is completely in different state. Okay, and I will say one more thing. Okay, let's see something else. Okay, we will come here, we will just have an inference of it. Petal width, petal length, whereas for vesicolor and virginica it is very high and also there is some correlation, whereas setosa is very low and it has no correlation with those two. Okay, guys, this is how you need to have an understanding. Diagonal is like, it says the distribution, whereas the other thing goes says the correlation in the pair plot. Hope you guys have enjoyed and understand this. Let me move for the next visualization. Okay, yeah. Next visualization, I'm gonna do the box plot. Guys, I love this box plot. Let me see why I am loving it. Okay, first I'm just setting the figure size, that is 12 cross 6. That is how much the figure should be. Now, SNS does box plot. I'm gonna use X label. I'm gonna use the species. What are the species? Setosa, virginica, and vesicolor. And y-axis, I'm going to use the sepal width. And what is the data? Iris is the data. Now I'm going to print the title of it. that is sepal length distribution by species, and then I'm going to show it. Okay, in x-axis I'm going to have the species, that is Setosa, virginica, and vesicolor. Y-axis is the sepal length. Sepal length. Okay, guys, I will just give 5 seconds. Look into it. The title is sepal length distribution by species because we are having here. Okay, so I will give 5 seconds, guys. Just look into it and I will give the inference. Okay, it's over, right? Yeah, guys, see here, we are having dots here, right? They are called as outliers. Now we will look into this box. This line is a minimum value. This line is a maximum value. This line is a mean value. This is the first quartile and this is the third quartile. Don't worry about this, guys. I'm going to explain step by step. Okay. This plot will tell if there is any outlier in the data. If it is out of this box, these 2 points are outlier for this virginica when it is compared to the sepal length. Okay, these 2 points. Other thing doesn't have outlier. Now let us infer this. Okay, I'm saying this mean value, right? Let's see. What I'm gonna do means I'm gonna create a filter. Okay, this is a filter. Iris is a dataset name. Species, I'm just using the Setosa. What this highlighted thing will do means it will have only Setosa column. Now in the Setosa column, I'm going to choose only sepal length. Sepal length. And what is its minimum value? Its minimum value is 4.3. Okay, that is in Setosa feature, the minimum value of sepal length is 4.3. It's right. It's 4.3. This is the minimum value. Now I'm just gonna change this min to max. That's it. What is the max? 5.8. Come here, 5.8. Right, somewhat near to 5. Yeah, it's 5.8. The min, max, and this is mean, right? Just change this to mean, max to mean. That's it. What does it mean? I think it's 5. Yeah, we are also getting 5 here. 5.006. Next, 25%. That is 25% of value. What is it in the data set for Setosa? What is the 25 percentile of sepal length? Okay, how we can do it? Same thing. Change the mean to quartile of 0.25. That is this line. Okay, I think it will be around 4.8 something. Yeah, 4.8. That's right. So first quartile is 4.8. Now we just need to interpret this third quartile. I think it will be around 5.2. Okay, let's see. So I'm just gonna remove the replace it quartile. I'm just removing this 0.25 to 0.75. That's it. It will give the 75% of it. 75% of it. It is 5.2. Yeah, it is 5.2. Guys, this is how you need to infer the box plot. It's very, very important, very interesting, and I love this very much because it will show the outlier. So if it is a virginica and for sepal length, you just need to remove this. What is it? I think 5. And also when the data point is 7.9, you just remove these 2 data points. Now you have a data set more generalized and it will not have any outliers in any of the columns. Okay, related to sepal length, you need to just figure all other things. There is sepal with petal length, petal with all other things. You need to give the box plot. I'm just saying this is a overview. Just understand this. This is how you need to have an inference out of it. Okay, now yeah, explanation. Scatter plot we have seen, right? It is used to visualize the relationship between pattern length and pattern width. We have done there, and with different colors for each species. Then pair plot, it creates a pairwise plot between all features in the dataset, helping to see the correlation between variables. Yeah, that's true. Finally, we are seeing a box plot, right? Box plot shows the distribution of sepal length for each species, providing a summary of central tendency and spread. What is central tendency? Mean, median, mode. And then spread means first quartile and third quartile, like that we can have. Okay, so yeah, guys, so that's all about data visualization. This is what I'm having. So yeah, sir, over to you. I will just move on to the top. Okay, so yeah, yeah, sir, over to you.
Yeah, so data visualization, I think it's very well explained, guys. So I'll just touch, I'll summarize and I'll touch the important aspects only. So, uh, when we do data visualization, so here what we have to do is we have to understand data through, like, we have connected our data to the environment, whatever, whether you're using um, Python, or you're using Anaconda, or you're using any tool. Okay, you connect, and then you try to see that how it is looking. You have to overview it. You have to also do manipulation also, and then you have to do uh, data visualization. Now, in data visualization, we'll visually see numbers. We human beings don't understand numbers and text in that manner, and if they are in complex way, because we are talking millions of data sets, guys. So we are giving you example with this data set, but there will be millions of data sets. You can't really uh, understand if you are not visualizing. So how, what is the pattern? How you cannot find those patterns. So insights, that is why data visualization is very, very important. And when you are communicating to others, so they will also, you have to take screenshots and take these to reports when you're making reports, so that they will understand these. They Anybody can understand. Okay, so here we are these are basic data visualization to explore data. So figure size equal to 12 and 6, we have given this particular function, and then plot, we have to use scattered plot. Here we are using scattered plot, which you already know a lot of. We have discussed in the previous sessions that we scattered plot is one of the way to visualize data. Okay, so here we are using on petal length versus petal width, colored by species. So there are different colors we are given to different species. Okay, so that we can visualize. So Setosa we have given blue, Virginica we have given yellow, orange color, and we have given Virginica green, right? So see here, so they are scattered. So you have to see, so which species is where according to your standard. So your standard is, I think, what is our minimum and maximum here?
Yeah, for petal length you were asking, right?
Yeah.
Yeah,
Petal
it's
length,
from 1 to 7.
yeah,
Yeah.
1 to 7. So you can see 1 to 7 petal length we have, 1 to 7 you can see. So you can see Setosa in from 1 to 2, right, in petal length. But if you see in petal width, so it is 0.6, let's say 0.7, the petal width. But if you see other species which are Versica color, which is like orange color, it is beyond what, if you compare with Setosa, so it is beyond, it's nowhere where Setosa is, right? And if you see Virginica, which is in green color, we have given the color, so it is beyond Versica, right? So you can see correlation, that if now you can make inference, guys, here. So there is no correlation between Setosa and Virginica, guys. There is some colors, some angles, some dimensions are matching between Versica and Virginica. Okay, so this is how we can visualize based on petal length and petal width. We are giving these two dimensions to understand, and then see, if I have to see, okay, where is my market? Suppose if it is a marketing data, so we have to launch a product. So based on this data visualization, I will make decision that okay, where I need to start first, or where is the best, which region I have to go and start marketing and promoting my product. I'm giving one example. It can be n number of ways you can look at this particular 360-degree, you can look at this data. But the here, when you're going, you go and see numbers, you won't get that kind of visualization, which will, which when we use visualization, data visualization. So this gives us a lot of insights. We get a lot of ideas. You will have like I'll get a lot of feeling, lot of ideas, lot of insights from it. So that is the actual essence of data visualization, and then we document it and communicate it to stakeholders. Okay? Yeah. Let's go to the other one. Yeah, here we have given dimensions. So what is the, we have given dimension according to that. So we are getting the, we are getting sepal length, sepal width, petal width, as per the species, which is Setosa and Virginica. So we are comparing, okay? We are doing comparing these two. So yeah, so can we go down? Yeah. Yeah, yeah, here. I just want to, yeah, here again. So there is another way. So pair plotting, when you do pair means two. Uh, you do pair is two, means, so do you do pair plotting here, double dimension kind of thing. Iris feature on features. What are your features? Okay. Based on that, sepal length, sepal width. Can you move it up, little up? Yeah. So here pair plot, here you will see a lot of dimensions, and then here you will get more ideas about the data, the spread, which is spread shown in the scattered plot. But in pair plot, here you are doing, you will compare. Yeah, you will see, you will understand data with different dimensions, huh? Based on these three species. We have three species right now, based on sepal length, petal width, petal length, sepal width, and sepal length. So based on that, and here we have three species, and here we can do correlation kind of thing, and we'll understand data in a different way, the way we did it in previously. Now we'll go more detailed way visualization. What I'll say, detailed visualization, comparing different aspects of the data. Okay, and this is how we can get more insights, and then we can document those insights and communicate it to stakeholders. Like I'm saying, after you build this, but right now you can do that. You can get insight and feel of data at pre-processing. So you will get feel of data, what kind of data I have, how it is looking, how it is feeling, and then based on that you can make changes to your data. So I was giving reference for once you build the model, you make final report. That time also you can do such visualization so that you build a great report. So I'm going into future, but